The third section of the review questions focus on derivatives. And so our first problem, we're given a function f of x equals 8 sine of 3x. And our task is to find the equation of the tangent line at an x value equal to pi over 12. So, to find the equation of a line, we need two pieces of information. We need to know a point, and we need to know the slope. To find the point, we're going to use the y value if I plug in pi over 12 for my x value. So I just use the original function, 8 times the sine of 3 times pi over 12, or 3 pi over 12, which simplifies to the value 8 times the sine of pi over 4. That happens to be a 45-degree angle, and so it's 8 times the sine of pi over 4 is root 2 over 2. So we get a value, our y value, is 4 square root of 2. Alright, so this tells me that my point has an x-coordinate of pi over 12 and a y-coordinate of 4 square root of 2. The second thing we need is my slope. And my slope is given by the derivative at pi over 12. So we need to find the derivative. F prime of x is the derivative of our original formula, which is the derivative of 8 sine of 3x. 8 is a constant multiple. So we multiply 8 times the derivative of a sine is cosine. So it's cosine of 3x. And then the chain rule, I need to be sure that I take a derivative of 3x. So I get times, oops, not equals, times the derivative of 3x is 3. So my derivative is 24 cosine of 3x. And I'll use that to find the slope. The slope is f prime of pi over 12, which is 24 times the cosine. 3 times pi over 12, we learned earlier, was pi over 4. Again, that has a value of square root of 2 over 2. And so I get a slope of 12 square root of 2. Once I have an equation an equation of a value for the point and a value for the slope, the equation for the line is y minus the y value is the slope times x minus the x value. And so our y value was 4 square roots of 2. Our slope was 12 square roots of 2. And our x value was pi over 12. So we'll add 4 square root 2 to the other side, and we get an equation y equals 12 square root 2, I'm looking ahead, 12 square root of 2, x minus pi over 12, plus 4 times the square root of 2. And this is the equation of the line using the point-slope form for the tangent line of our function at pi over 12. The next problem in this section is to calculate the derivative of a quotient, which means we need to sing a song. Low-de high minus high-de low over low-low. My function that we start with, f of x, is 2 minus 3 times the sine of 2x, all over 1 plus the cosine of 2x. And so when I talk about low and high, the top, the numerator is my high, the denominator is my low. So my derivative is low d high minus high d low over low low. So for this problem, I get 1 plus cosine of 2x, that's low. D high, the derivative of 2 is 0. The derivative of Sine is cosine, so I get negative 3 cosine of 2x. Chain rule says times the derivative of 2x, which is 2. There's low d high minus high d low. Probably should have written that on another line. Minus high d low 2 minus 3 sine of 2x times the derivative of the denominator. So I get derivative of cosine is negative sine of 2x times 2. That fraction all goes over the denominator squared. 1 plus cosine of 2x squared. And now we'll start to do some algebra and simplify this. So I need to be sure that I distribute these terms on the multiplication. So in the numerator of f prime, 1 times negative 6, so I get negative 6 cosine of 2x. And then I get negative 6 cosine times cosine, so I get minus 6 cosine squared of 2x. Now I'll do the next term. So I get 2 times negative 2, so that's negative 4. We are subtracting negative 4. So we get plus 4 sine of 2x. And then I get sine times sine. So we get 6 minus 6 sine squared of 2x. And still all of that over 1 plus cosine of 2x squared. Alright. When it asks us to simplify, one of the things that we should notice is we have minus 6 cosine squared, we have minus 6 sine squared. Those two terms can be grouped. So let's factor out that negative 6. Negative 6, we get cosine squared of 2x. And factor out from, we're left with sine squared of 2x. Then we get minus 6 cosine 2x plus 4 cosine plus 4 sine 2x over 1 plus cosine of 2x squared. And the reason we group that term out is that I have a Pythagorean identity term that can be simplified. Sine squared plus cosine squared of the same angle is always equal to 1. And so my final answer is I'm going to get negative 6 times 1, so negative 6, minus 6 cosine of 2x, plus 4 sine of 2x, all over 1 plus cosine of 2x, all squared. And that is the simplified formula for the derivative. The third problem asks us to just calculate the first and second derivatives. So my original function is the tangent of x squared. So to calculate the derivative, f prime, the derivative of a tangent is secant squared. So we'll take secant squared of x squared, and the chain rule says now multiply by the derivative of x squared, which is 2x. We usually write that as 2x secant squared of x squared. As I get ready to take the second derivative, I need to take note that I now have a product in my first derivative. And so I need to use the product rule. we have two terms. So we will take a derivative of 2x, leave the secant squared alone, and now we'll add what happens when we take 2x and take the derivative of secant squared. Well, to take the derivative of secant squared, that is a power of secant, so I need to use the power rule. 2 times the secant of x squared to the first power. That's the derivative of this power 2, times the chain rule factor, which is the derivative of the secant of x squared. Derivative, I'm just going to write this so I keep track of things. The derivative of what was inside secant squared, sorry, not secant squared. The secant, changed colors accidentally, the secant of x squared. Okay, so I had 2 times the secant of x squared to the first power, derivative of secant of x squared. Alright, so there's nothing I can do the first term, so let's just write it down again. Secant 2 secant squared of x squared plus 2x times 2 secant of x squared. And the derivative of secant is the secant tangent. So I put x squared in both parts. But the chain rule says, ran out of space, we'll have to multiply by the derivative of 2x. And just an observation, a lot of students think that because I have a secant and a tangent, that I should somehow have 2x for each of them. But that's not what it is. The derivative of a secant is the secant tangent. And so I get secant tangent of the same formula, x squared, times the derivative of the x squared. And that only appears once. So now we can finally start to group our terms. Again, this first term, we just get 2 secant squared of x squared. But for the second one, let's figure out all the factors. So I get 2, 2, 2, so that's 8. We have an x and an x, so that'll give me x squared. I have secant of x squared, secant of x squared, so I'm left with secant squared of x squared. And I'm left with a lonely tangent of x squared. And this is the second derivative of our function. So we have our first derivative and our second derivative. The fourth question is actually simpler than the previous one. I need to take a derivative of sine to the fourth power of 3x. So my original function, f of x, is really the sine of 3x. That is put into the power function, so it's the fourth power of the sine of 3x. So when I take the derivative, in the context of a chain rule, I have u to the fourth where u is equal to the sine of 3x. And so my derivative would be 4u cubed, 4 sine of 3x cubed, now times the derivative of what was inside, that's the du dx. And the derivative of the sine is the cosine of 3x. And then times the derivative of what's inside, 3x has a derivative of 3. So my final answer is 12 sine cubed of 3x times the cosine of 3x. If I were to reorder the problems, I would probably switch the order of 3 and 4. 4 would more naturally come after this one. The fifth problem in this section is to find the derivative of the exponential of the cosine of the reciprocal of x. So when I want to take a derivative, see, for notation, I always like to redefine and say what my function is. This is the exponential of the cosine of the reciprocal, or minus 1 power of x. So when I take a derivative, the derivative of the exponential is itself. It's e to the same thing, cosine of 1 over x. But then I need to take a derivative of that cosine. And the derivative of a cosine is negative sine. So I get the exponential times the negative sine of the same thing, the reciprocal of x, times the derivative of what was inside. 1 over x and x to the minus 1 are the same power. X to the minus 1 power. And so I'm left with, let's put that negative sign in front, negative exponential of cosine of 1 over x times the sine of 1 over x times negative 1x to the minus 2 using the power rule. So multiplying the negative and the negative 1, I get 1. I get x to the negative 2, so that's 1 over x squared. The exponential of cosine of 1 over x times the sine of 1 over x. And be sure that that sign does not look like it's in the power of the exponential. That's it. The sixth problem in the section of derivatives is to calculate the derivative of the logarithm of the tangent of x. I'm actually going to show you two ways of doing this. First, if I think of my function f of x as the logarithm of the tangent of x, then when I take my derivative, f prime, the derivative of a logarithm is u prime over u. And my u here is the tangent of x. So u prime is secant squared. So it's secant squared of x over tangent of x. Now, I need to simplify this. The secant means 1 over cosine. So what I really have is I have 1 over cosine squared of x. That fraction is divided by sine over cosine. And so a fraction over a fraction really needs to be simplified. I'm going to multiply top and bottom by cosine squared. That'll simplify both terms. So cosine squared of x, cosine squared of x. And the reason I multiply by the same thing on top and bottom is that's like multiplying by 1. It doesn't change anything. I mean, it changes the formula, but it doesn't change the value. So in the numerator, the cosines cancel, and on the denominator, only one of them cancels. So I get sine x, cosine x. And one way to see that 1 over sine of x is the cosecant, and 1 over the cosine is the secant. Well, the second way to do this problem is to think of tangent. So f of x is the logarithm of the tangent. So that's the logarithm of sine of x over cosine of x. And so by the properties of logarithms, I can split this into two pieces. It's the logarithm of the sine of x minus the logarithm of the cosine of x. So that when I take a derivative, f prime of x, I get the derivative of the logarithm, that's u prime over u. So this time it's the derivative of sine is cosine. So cosine of x over sine of x and then minus, this time we'll put cosine of x in the denominator, and its derivative is negative sine, so it's minus negative sine of x, which gives me cosine over sine, that's the cotangent, and the two negative signs cancel, so I get plus. Sine over cosine is tangent of x. So an alternate expression for the same thing is cotangent of x plus tangent of x. That's a little surprising. We have two answers that don't look a lot alike. And I want to show you that we can recover our original formula if we notice that I could get a common denominator. So I get cosine and sine. Here I have sine. Here I have cosine. To get a common denominator, I need to multiply the first times the cosine. So I get cosine squared of x over sine x cosine of x. In the second term, I need to multiply top and bottom by sine. So I get sine squared of x over sine x cosine of x. When I add the numerators, cosine squared plus sine squared, that's a trig identity. The Pythagorean identity says that's 1. I get 1 over sine of x cosine of x. So in fact, our two answers are actually the same. They're just different ways of writing it.